Part 2, the toolkit functions. Intercepts. Suppose the graph of an equation is given. A point on the graph that is also on the x-axis is called the x-intercept of the graph, and a point on the graph that is also on the y-axis is called a y-intercept of the graph. Let's look at this graph right here. The x-axis is the horizontal axis, and we have 2 points on the x-axis, when x is -5 and when x is -1. Notice that the y values of those 2 points is 0. So the x-intercepts are the points -5, 0 and -1, 0. The y-intercept is right here. That is where x is 0 and y, it looks like maybe -1.7. We're approximating there. But the x value is 0 when we are on the y-axis. The toolkit functions, which we can also call the parent functions. This is a group of functions that the graphs need to become familiar to you. You should have an idea of what these graphs look like and how to use them. So the first one would be our constant function. The equation might just look like y equals some number, y equals k. So for this one here, I have a graph. A constant function is just going to be a horizontal line. This one is y equals 2, but 2 could be any constant here. Our domain of this function, what is the domain? If I look at the arrows that go right and left, it's showing that the domain is all real numbers, -∞ to infinity. The range is just the number 2. And the intercepts are the point, just one intercept, it is the point 0, 2. The identity function just looks like y equals x. So x and y are equal, and we have this green line right here. The domain of this function is all real numbers, -∞ to infinity, and the range is also all real numbers, -∞ to infinity. The only intercept here would be at the origin, right here. That is the only place either axis is intersected, and that is at the point 0, 0. The next function is the absolute value function. The absolute value function looks like a V, where the lowest point is at 0, 0. The domain of this function is still all real numbers. We can take the absolute value of any real number, but the range is all non-negative real numbers. So the range starts at 0 and goes to infinity. The intercepts, again, there's only one intercept, and it is at the origin at the point 0, 0. The next toolkit function is y equals x squared, and we might call that the squaring function. This graph is a parabola, looks kind of like a U shape. The domain of this function is all real numbers because we can square any real number. The range is all non-negative real numbers because the smallest number you can get after squaring a real number is 0. And then the intercept, again, our only intercept is the point 0, 0. It is both the x and the y intercept. The next function, y equals x cubed, we could call the cubing function. The shape of the graph looks like this, where it goes up on the right and down on the left. The domain of this function is all real numbers. We can take any number and we can cube it. The range is also all real numbers because any number can be cubed, and then we can get out. If we plug in a positive number into x cubed, we get a positive number. If we plug in 0, we get 0. And if we plug in a negative number for x, we get a negative number for y. The only intercept is, again, the point 0, 0. The next function in our toolkit is y equals 1 over x. This is called the reciprocal function. And the graph looks like this. It has 2 branches. The domain of this function is all real numbers except for 0. So in interval notation, that looks like -∞ to 0, unioned with 0 to infinity. The reason why 0 is not part of the domain is because 1 divided by 0 is not defined. The range of this function is also all real numbers except for 0, because 1 divided by x will never be 0, no matter what x is. The intercepts of this function, well, there are no intercepts. Notice that our domain and range are both excluding 0, and our x-intercepts would have a y value of 0, our y-intercepts would have an x value of 0, but those are not possible because 0 is not in our domain or range. The next function, 1 over x squared, would be the reciprocal squared function, and it looks like this. So this one, our domain is still all real numbers except for 0, but now our range is all positive real numbers. because when we square that x, it then becomes positive, even if it started out negative. There are also no intercepts here, because 1 over x squared will never be 0, and x also cannot be 0. The next function in our toolkit is y equals square root of x, or the square root function. This graph looks like this. So we start at 0, 0, and then it goes toward the right. Our domain is all numbers from 0 to infinity. We cannot take the square root of a negative number, but we can take the square root of 0 or any positive number. Our range is also all the numbers from 0 to infinity. And the intercepts, again, we have that one intercept at 0, 0. The next one is the cube root function, y equals the cube root of x, which looks like this. Our domain of this function is all real numbers, and our range is also all real numbers. And again, our only intercept is 0, 0. This function is what we call the greatest integer function. So the definition of this function is whatever we substitute in for x, we're looking for the greatest integer that is less than or equal to x. So if I were to substitute in, let's say 1, if x was 1, then I would have y is the greatest integer less than or equal to 1. Well, 1 is less than or equal to 1, so I have a point at 1, 1. But what if I plugged in for x 1.5? So then I want the greatest integer less than or equal to 1.5. The greatest integer less than 1.5 is 1. So 1.51 is another point on this graph. Our domain of this function is all real numbers, but our range now is only the integers because every output is going to be an integer. The intercepts, we have x-intercepts everywhere between 0 and 1. Everywhere here is an x-intercept, not 1, but 0 is an x-intercept. So that reads the set of all points a comma 0, such that 0 is less than or equal to a is less than 1.